little bit of vocabulary we need to refresh our memory on. Remember from a couple of chapters ago that when we have similar figures, they have a scale factor, and their scale factor is just a fraction. It's a comparison of their size. All right, so let's consider these two squares. Badly drawn, but hopefully you get the idea. If the side length of this square is 2 and the side length of this square is 3, do we visually see that their scale factor would therefore be 2/3? Ratio of corresponding sides. What would be the perimeter of the small square? What would be the perimeter of the small square? 8. What would be the perimeter of the larger square? 12. So then the ratio of their perimeters would be what? 8 to 12, which reduces to 2/3, the same as the scale factor. Okay, so if two similar polygons have a scale factor of A over B, then the ratio of their perimeters will also be A over B. Do you think that the ratio of their areas will also be A over B? No. What do you think it will be, sir? Absolutely. So we can use that property to find areas of similar figures, find perimeters of similar figures. Let's start simple, though. In problem 1, we are given the ratio of their corresponding sides, and we are simply asked what will be the ratio of their perimeters and what will be the ratio of their areas. So if their scale factor is 3/4, what's the ratio of their perimeters? Also 3/4. How about the ratio of their areas? It would be 9 over 16. Okay? Pretty elementary so far. There's a your turn. Please work through that quickly. So simply enough, the ratio of their perimeters, remember, will be the same thing as the ratio of their sides. So the ratio of their perimeters will be that same 5 over 7, whereas the ratio of their areas...
7 over 5.
Well, oh, it says larger to smaller. Thank you. Good eye. So in problem 2, we start to take a look at how to use this ratio of areas to find the area of a figure. In problem 2, notice I'm given the area of the smaller hexagon and I'm asked to use that to find the area of the larger hexagon. So you may have noticed this lesson is dealing with a throwback to chapter 7, where we were talking about similar figures. And when we were dealing with similar figures, do you remember what most of our problems boiled down to as far as what my equations looked like? Proportions. Yes, that's exactly what we're doing here. So, is 7 over 10 in my proportion? No. 49 over 100 is in my proportion. Because I am dealing with area, I must be using the ratio of areas. So I have to square that scale factor before I put it into a proportion. So on the other side of the equal sign, where am I putting that 127.3? Top or bottom? Absolutely. And then you're just solving for x. And since The area of the smaller hexagon is rounded to the nearest tenth. I would say it would be proper notation to approximate the larger area also to the nearest tenth, so 259.8 square feet. Your turn for this problem is a Centillo question, so please work through that. And when you have found the area of the smaller parallelogram, please type it into your Centillo. That's it. The only thing that's really difficult about this lesson is remembering to square that ratio before you set up your proportion. Again, when you find the area of the smaller parallelogram, please type it into your Centillo. Okay, still waiting for a couple of you to wrap this up. Again, when you found your answer, please enter it in your Centillo. Okay, once again, still waiting for a few of you to finish this up. When you have your answer, please type it into the Centillo. Okay, fantastic. Our overwhelming majority is the correct answer of 54. To clarify, if my scale factor is 3/4, is that the number that's going into my proportion? No, I'm dealing with finding the area in this problem, so I need to square that ratio to 9/16, and then set that equal to x/96. We have from this screen what we need. We're good? Okay, in problem 3, we're taking this and applying it to the real world. Decorating. Fun. So it costs Maria $150 to have carpet installed in one room, and we want to use those dimensions to find how much it's going to cost to carpet a larger room. What is my scale factor? What is my scale factor? It's 12/18. And of course, let's reduce that. That's 2/3. So now, how am I going to use that 2/3? Notice I'm seeing some confusion. The larger dimension of the family room is given to us as 18, so that's what I would compare to the larger dimension of the room that I was given. So that's where the 12 over 18 is coming from. Better? No? All right, let's backtrack. In both of these problems, we had the scale factor basically given to us. Here, it was visually given, this is 7, this is 10. I knew to set up 7 over 10. Here, I was given the scale factor in no uncertain terms. Here, I have to really read the problem carefully to figure out where that scale factor is. So, I've got 2 rectangular rooms. I know that one of them is 12 by 10. The other room I don't know both dimensions for, but I know that the larger dimension is 18. Now we see the 12 over 18. So my scale factor is 2/3. How am I using that to figure out how much it's going to cost to carpet the larger room? Am I putting 2/3 in a proportion? No, because I'm carpeting a room. Carpet is sold by the square foot. I need to square this scale factor. So I have 4 over 9 that I'm putting in a proportion. Where's that 150 going? Top or bottom? And it should cost $337.50. Your turn for this problem is also a Centio question. Please work through that within your island. And when you find its answer, enter it into the Centio. Keeping in mind, this is money. Make sure that your answer looks like money. What is the maximum number of decimal places that money, right, make sure that you're only giving 2 decimal places. I'm sorry? Yeah, you still round up where it's appropriate. For our purposes of seeing green up there, don't. But I will make a point about it. Thank you. Please. Okay, still waiting for a few of you to key your answer in. Okay, so in retrospect, let me make a point in retrospect. So I was asked previously, Mrs. Klaus, do you round up for money? And I was thinking along the lines of, if you would normally round up, go ahead and round up, but I wasn't thinking along the lines of, if you've got more than, for example, in your calculator, this was 6.94 repeating. Money-wise, a seller would probably round that up to $6.95. So absolutely count yourself correct if you typed in 6.95 as well. 4.17, if I had to guess, I would say you forgot to square that ratio. The others were just inappropriate rounding. Any questions on this one? Okay, looking good. This time, notice we're asked to work backwards, gentlemen and ladies. We're asked to work backwards. We know the areas of these figures. We're asked for their scale factor. How will I do that? Right. Okay, but looking at this ratio, 32/50, and thinking about taking the square root of that, maybe you're already going, ew, that's not going to work out so pretty. But maybe you look at that fraction one more time, reduce it. And when it reduces, oh, that's much prettier to take the square root of. So when we take the square root of this, our scale factor becomes 4/5, which means that will also be the ratio of their perimeters. Your turn for this is not a centile question. Please turn the centiles off. Don't worry about bringing them up just yet. But do work through that problem. Being forewarned, it doesn't work out as nice and pretty as this last. You can't reduce the fraction. And remember, gentlemen and ladies, if you have a scientific calculator, it will reduce fractions for you. You type it in as a fraction and hit equals. It may revert to a mixed fraction, but your calculator can change it back to improper as well.
I'm getting a decimal.
In your fraction of your calculator, let's change that to improper. Second fraction. Now we need to take the square root of. In your fix, how to type it in as a fraction. So here's your fraction. You need to make sure you know how to use your classic. These are fantastic little tools you have, gentlemen and ladies, and some of you don't know how to use them. All right, so when you take this 1875 over 135, it reduces to 125 over 9. And one of those you can take the square root of without any difficulty. Square root of 9 is just 3. But when you take the square root of 125, that's not pretty. So how would I simplify the square root of 125? It's 5 times the square root of 5. And that would be my ratio of perimeters. Okay, so looking at this square root of 125, we simplified that 125 down to 25 times 5. And then you know that the square root of 25 is 5. Fantastic. All right, I have a daily quiz on Socrative that I will be activating.